Alright. The unit circle, okay, as most of you know, okay, those of you that took pre-calc already, know the unit circle is a very useful tool in letting us memorize lots of specific trig function values, sine, cosine, tangent values. What the unit circle actually is just a circle of radius 1. Right? So the radius, which means the distance from the center to any of these points on the unit circle, that distance is 1, radius is 1. So, first of all, okay, we can find some of these coordinate points on the unit circle very easily. So if this, okay, we're saying this is the x-axis here. So if I start at 0, 0, you can mark that that's 0, 0 if you want, and I go a distance of 1 along the x-axis, what are the coordinate points, or what is the coordinate point here? 1, 0. Right? How about straight up here? 0, 1. Okay? Okay, we'll talk about what that actually means and why that's useful here in a second. But first, we want to build our values here. So we assume that this angle, okay, if I look at this angle right here, we're saying that this is a 30-degree angle. Okay? This is a 30-degree angle. So we're going to look at this right triangle here to try to figure out what the coordinates of this point are. Well, what we know is that this length is 1. The hypotenuse of this right triangle has a length of 1. It's nice. Can't use that on any tests or quizzes in here. So, we've talked about our special right triangle relationships. Right? So if I know that this is a 30-degree angle here, obviously we know this other angle in the triangle is 60, and my hypotenuse has a length of 1. Okay, well, we've talked about the relationships in a 30, 60, 90 being the side opposite 30-degree angle we can call x. The hypotenuse is exactly double that. And then the side opposite the 60-degree angle is x times the square root of 3. So if we use that information here for this triangle, we know that the hypotenuse is 1. What are the lengths of these two sides of that right triangle? How would we figure that out using this relationship here?
I don't really know what that, like, what are you asking?
So we've talked about this relationship, right, in a 30, 60, 90 right triangle. So that's what's happening here. We know that this is a 30-degree angle. And what we know, since this is the unit circle, a unit means the radius is 1 unit. So we know the hypotenuse of this right triangle is 1. So we want to use the relationships that we already know in a 30, 60, 90 right triangle, and knowing that the hypotenuse is 1, to find the length of these two sides. So how would we do that? This one is going to be a half, right? Because I know that the hypotenuse is exactly twice the length of this side. So if this is 1, this will be half of 1, which is 1/2. Right? So now, I can see that this side is just this side times the square root of 3. So if I take 1/2 times the square root of 3, I'll get the square root of 3 over 2. Right? So if we're looking at this right triangle here, we're saying that the distance from the origin to this edge is the square root of 3 over 2. That means that's going to be the x-coordinate of this point right here. The y-coordinate then is just going to be 1/2. Okay? From 0, 0, we're going a distance of the square root of 3 over 2, and then I'm going a distance of 1/2. So that point on the circle, those are the coordinates. You okay with that? So our next angle that we're going to look at is a 45-degree angle. Right, this angle right here. It says in the directions. I don't remember which one it says. Okay, so if we look at our relationships in a 45, 45, 90, okay, we said that the relationship was this. If each of the sides are x, the hypotenuse was just one of those sides times the square root of 2. So now, what we know, this right triangle here, we know that the hypotenuse is 1. So knowing that, and knowing this relationship that we already talked about, how would I find the length of the two legs here?
I should know the number. Once you already figured it
Well, you should know how to get them.
out. See, gotta, you know.
What if I give you a 45, 45, 90, and I say that one of the legs is 6? How would we find the other two sides here?
6 multiplied by it.
Yeah, so this side we would just multiply by the square root of 2 to get the hypotenuse. Well, think about going backwards. If we know the hypotenuse, to get to here, I would take the hypotenuse and divide by the square root of 2. Alright, so if I know that the hypotenuse is 1, I'm going to take that value and divide by the square root of 2.
3.7. That's pretty fancy.
So I'll just have 1 over the square root of 2. Remember, though, we need to rationalize denominators. If we have a square root, so I would multiply top and bottom by the square root of 2, and we'll end up with the square root of 2 over 2. We know the two values, or the two legs, in a 45, 45, 90 are the same. So if this leg is the square root of 2 over 2, so is this leg. So if we're thinking about this right triangle here, the x distance is the square root of 2 over 2, and the y distance is the square root of 2 over 2. So those are our coordinates for this point right here on the unit circle. Now, our final triangle here is a 60-degree angle. So this one, markers,
Nice.
not doing so well.
So I feel one of them in this class doing the way that marker sounded.
So we already looked at our 30, 60, 90 when it was turned this way, right? We already determined the values of that right triangle. Okay, but now we're just taking that triangle and turning it the other way. So now if we're saying this angle is 60, this angle is 30, these were the values that we found. Right? 1/2 and the square root of 3 over 2. So now we're just saying, well, this distance, the side opposite 30, is now 1/2. And this distance, the side opposite 60, is the square root of 3 over 2. So my coordinates then would be 1/2 for the x distance and square root of 3 over 2 for the y distance. Okay? Now, the reason that these values are significant, if I look at this triangle here and I write out some trig functions, okay, so if I think about sine of my 60-degree angle, well, we know that sine is the opposite side over the hypotenuse. So sine is going to be square root of 3 over 2 over 1. Right? Cosine of 60 degrees is the adjacent side over the hypotenuse. So that'll be 1/2 over 1. The unit circle is very useful because our denominators here, when we're looking at our trig ratios, will always be 1, because the hypotenuse of all of these right triangles is just 1. So what we can say is the coordinates of these points give us those trig values. On the unit circle, right, this is an important piece of the unit circle. Every single coordinate point, the x value gives me the cosine of that angle. The y value gives me the sine of that angle. So that's why we memorize these values on the unit circle. Because, again, we talked about this idea before. The sine of 60 degrees is always square root of 3 over 2, no matter how large the triangle is. That ratio will always stay the same. Okay, if I take a 60-degree angle and take the opposite side over the hypotenuse, that will always reduce to the square root of 3 over 2. If I find the cosine of a 60-degree angle, no matter how large the triangle is, that ratio of the adjacent side over the hypotenuse will always be 1/2. Right? That's why it's useful to memorize these values on the unit circle. Right? So, once, and I know even if you memorized it last year, you probably don't have it fully memorized right now. Okay? But if I look at this information on the unit circle, and I ask you for the cosine of 45 degrees, okay, well, you should be able to say, well, 45 degrees is here, cosine is the x value, cosine of 45 is square root of 2 over 2. Okay? Sine of 30 degrees. Well, 30 degrees is here, sine's the y value, sine of 30 is 1/2. Okay? And that's true, again, no matter how large that triangle is. Okay? We just memorize these values on a circle of radius 1 so that we know those trig values. Once we have the first quadrant built here with these values, getting the other 3 quadrants is pretty straightforward because all we're doing is reflecting over the x and the y axis. So, I need to zoom out a little bit here. So, you said this was 30 degrees, 60 degrees, 45 degrees, 60 degrees, 90 degrees, 0. So this was so this is the information that we've built so far on our unit circle. Now, I'm just going to take these points and reflect them over the y-axis. Okay, so I guess first we need to figure out what angles those are going to create, and then we can fill in the coordinate points. So if I take my 60-degree angle, okay, well, from 60 to 90 is an additional 30 degrees. So then if I'm reflecting that point, bless you, over the y-axis to get to here, that's going to be an angle of 120 degrees, okay, because we're thinking from here to here. That's a 120 degree angle. And well, bless you. If I'm going then from here and reflecting across the y-axis, we can also think about from 60 to 40 is 15 degrees, so from 120, an additional 15 degrees will get us to, I guess I should be consistent with those on the same lines. 120 degrees, then another 15 degrees would be 135. Then from 45 to 30 is another 15 degrees. So over here, 150 or 135. Additional 15 degrees will be 150. And then obviously this angle here would be 180 degrees. So now if I look at those coordinate points, right, if I'm taking those and reflecting them over the y-axis, what coordinate is going to change? If I take any point and reflect it over the y-axis, the x value will become negative. The y value will stay exactly the same. The x value will be negative. So if I'm taking this point and reflecting over the y-axis, this coordinate at 120 degrees will be negative 1/2 square root of 3 over 2. If I'm taking this point and reflecting over the y-axis, that'll be negative square root of 2 over 2. Square root of 2 over 2. If I take this point and reflect it over the y-axis, that'll be negative square root of 3 over 2. 1/2. And then finally at 180 degrees will be a negative 1, 0. So now, in the third quadrant, I'm just taking these values and reflecting over the x-axis. So I guess, again, we need to figure out our angles first. So if I'm going an additional 30 degrees here, from 180, that'll get me to 210. And then each of these increments are 15 degrees. So this will be an angle of 225 degrees. 240 degrees here, and then this angle, 270 degrees. So now finally taking these points and reflecting over the x-axis, well, now the x-coordinate is still going to be negative, but the y-coordinate is also going to be negative. So this point right here is taking this value, reflecting over the x-axis. So this will be negative square root of 3 over 2, negative 1/2. This one will be negative square root of 2 over 2, negative square root of 2 over 2. This value, taking this point, negative 1/2, negative square root of 3 over 2. And then finally, the fourth quadrant, okay, again, filling in the angles. So a 30-degree increment here. This will be 300 degrees, and then each of these are 15-degree increments. So 315, 330, and then finally, once we get all the way way back around, this would be 360 degrees. So now taking these coordinates and reflecting over the y-axis, the x-coordinate will now be positive, and the y-coordinate will be negative. So this will be positive 1/2, negative square root of 3 over 2, positive square root of 2 over 2, negative square root of 2 over 2, and positive square root of 3 over 2, negative 1/2. And I guess we forget to fill this one in. That would be 0, negative 1 for those coordinates. Right, so this information tells me the sine and cosine of any of these angles. Right? The cosine is the x value for the unit circle, and the sine is the y value. The easiest way, I think, to remember that, okay, if you ever get mixed up on which one's which, is and south, cosines first, then sine. It's crazy because you guys go there, so it kind of works out. Okay. So cosine is the x-coordinate, sine is the y-coordinate of all of these points. Now, the only other thing left to fill in for each of these values is the radian measurements of these angles. Okay, so we've talked about converting between degrees and radians and using radian measures already the first few sections. So we also want to be able to fill in the radian measure of each angle. Right? So for now, I mean, we can think about using our conversion factor. Right? Our conversion factor was multiplying an angle by pi over 180. So if I want to convert 30 degrees to radians, I would just take 30 times pi over 180. So we just want to reduce that fraction. 30 over 180 would be 1/6. So 1/6 pi, or pi over 6. So a 30-degree angle, in terms of radians, is the same as pi over 6. Oh, sure. We can do the same thing for 45 then. 45 times pi over 180. So reducing the fraction of 45 over 180 is just 1/4. So 1/4 pi, or pi over 4. $60 degrees then. 60 times pi over 180. 60 over 180 will reduce to 1/3, or pi over 3. Okay, we can do that all the way around the unit circle and get these radian measures. Okay, now what we're actually doing here, we can start looking for patterns. 30 degrees we know is pi over 6, and most of these increments, if we ignore the 45, 135, 225, and 315, most of these are 30-degree increments, or pi over 6 increments. So if 30 degrees is pi over 6, and I go another 30 degrees, I'll be at 2 pi over 6. 2 over 6 is the same as 1/3, right? So this is 2 pi over 6. Another 30 degrees would be 3 pi over 6. Well, 3 over 6 reduces to 1/2. Then another 30 degrees would be 4 pi over 6. 4 pi over 6 would reduce to 2/3 pi, or 2 pi over 3. Then if I go another 30, I'll end up here. So this was 4 pi over 6. This one's going to be 5 pi over 6. Another 30 would be 6 pi over 6. It would just be 1 pi. Another 30, 7 pi over 6. another 30, 8 pi over 6. 8/6 would reduce to 4/3. Then another 30, 9 pi over 6, where that would just be 3 pi over 2. Another 30 would be 10 pi over 6, which would reduce to 5 pi over 3. Another 30 would be 11 pi over 6. And then another 30 would be 12 pi over 6, or 2 pi. Okay, and we talked about the number of radians in a circle is 2 pi, so that should make sense. Okay, we could also say that this is 0 pi. We're starting and ending in the same spot. Then, to fill in the few that we're missing, okay, we want to think about our pi over 4, or our 45-degree increments. So, I know that my first 45 is pi over 4. Well, if I go 2 pi over 4, right, 2 times 45 is 90, so 2 pi over 4 is pi over 2. Then another 45 would get me to here, so that would be 3 pi over 4. Then another 45 would be 4 pi over 4. Then another 45 would be 5 pi over 4. Then another 45 would be 6 pi over 4. We already have this 3 pi over 2. Another 45 would be 7 pi over 4. Another 45 would be 8 pi over 4, or 2 pi. So, this unit circle allows us to express the trig functions of any of these angles, whether we express the angle in degrees or radians. Okay, so we could also say something like sine of 7 pi over 6. Okay, well, sine we know is the y value, so if I go to 7 pi over 6, the sine of that is -1/2. Okay, again, no matter how large that triangle is, if I know the angle is 7 pi over 6, I know the relationship between the opposite side and the hypotenuse is going to be this ratio. I could say the cosine of 7 pi over 4. Well, if I go to 7 pi over 4, the x value, the cosine, is square root of 2 over 2. Say the sine of 3 pi over 2. Okay, well, sine is the y value, so sine of 3 pi over 2 is -1. Okay. That's what makes the unit circle a very useful tool. Okay, we will have a lot of specific trig functions memorized. Questions on the unit circle? Alright, so we have finished the first 3 sections now in this chapter, so we're going to take a quiz on these first 3 sections. Part of that quiz, which I think we're going to do on Wednesday, alright, so we'll review tomorrow. Quiz on Wednesday, we'll be having the unit circle memorized. All right? I'll show you another small trick tomorrow. I don't think we have enough time today. I'll show you another small trick tomorrow that has nothing to do with the math. It's just a way to memorize the values.
Do we have to know how to get the values for those triangles, the 30, 60, 90, or the 45, 45, 90? Or can we just memorize? Yeah, do we have to do those, or can we just memorize like the actual sine cosine values for the circle?
Well, if you know the values, you should be able to regurgitate the triangles too.
Right. I guess. I mean, it's not going to be on the test though.
I mean, like, this part will literally be that sheet of paper, and you just fill in the values.
Right.
But I mean, that'll just be the first part of the quiz. The other parts will be types of practice problems we've been looking at in the first 3 sections here.
You missed it.
So you don't need the notes about it.
I just